And now we are going to have content or kubature components of BIM. The presentation is titled Komponenty kubaturowe NCN w National Children's Hospital Project w Dublinie. It will be delivered by Monika Filusch from Frescon Island.
Monika Filusch, and today I'm going to introduce you to the problematics of component and model creation based on the new National Children's Hospital in Dublin and its standing seam roof. But before we dive into it, let me very shortly introduce myself and our company to you. I have over 20 years of construction experience. My BIM journey started about 10 years ago. Still, through my working years, I was lucky to experience construction from many different perspectives. From behind the desk and many times first-hand on site. Unfortunately, I couldn't find any photos and I'm usually too busy to take any. But here are two I prepared earlier today. I was working as a construction manager and as a plasterer at the very beginning of my career. But for the last 13 years, Frescon has been my life. I'm one of the founders and the CEO. We have provided many small to large-scale projects from our main office location in Łódź and operations in Germany and Ireland. But more importantly, we do this with an incredible team of talented people, and here they are. The project I will discuss today is the National Children's Hospital in Dublin. It is in construction and is designed and coordinated in BIM Level 2. The hospital is going to provide 160,000 square meters of accommodation with a total of 6,150 rooms. The building has 2 basement levels, providing 1,000 car park spaces, and it is 7 stories high. There are over 100 companies involved in this project, from designers to subcontractors, who all have provided a total of 453 BIM models. The roof is 205 meters long and between 9 to 19 meters wide, about 4,400 square meters overall. In comparison, it is about half a football pitch. Our client Select Roofing, a leading roofing and wall cladding contractor in Ireland, engaged us to support them in creating a BIM model of the standing seam roof design. Select Roofing has an impressive project portfolio. However, this project differed in its complexity. The main reason that made the roof design complex were its oval shape, the curved roof area, and the narrowing of the oval shape towards the center of the building. A traditional approach to designing and coordinating this roof would have been significantly harder and would take much longer than in a 3D environment. The main goal was to create an LOD 400 coordination model to reduce clashes through early coordination, enabling redesign before the installation start on site, to forecast problematic areas that would need to be handled during construction, and finally, to produce panel layout and production drawings for our client. Before I go into the details of how we created the model and what we learned on the way, let me give you a perspective of the scale of the model itself. The model in its final state consists of 1,439 panels. This includes 2 main Revit families and 163 family types. The panels ranged from only half a meter to 21 meters in length, and if we were to align all panels one after the other, we could get a total length of about 13 kilometers, or 1.5 times the height of Mount Everest. It also consisted of 5,083 C-channels, 10,710 halter clips, and 373 flashing and gutter elements. So, how to plan your work when you don't quite know where to start? Well, that was what we asked ourselves when we started this project. We began by reviewing the architect's design to understand it better. We were looking for similarities and repetitiveness. We knew that this would be helpful through the modeling process and the installation phase. We reviewed the setup of the grid lines, the roof arc constraints, the overall layout, and of course the chimneys. We also spent a lot of time testing all possible Revit family parameters and combinations to find the optimal solution. From this point, we could decide how to distribute the panels, how many Revit families were required, and how to set them up. This was the most important step. Good preparation was essential to enable a smooth modeling and coordination process. Our second challenge was to keep in line with design constraints. The chosen panels for this roof were curved, straight and tapered calcip aluminium standing seam profiles. The width of a panel could not exceed 450 millimeters at its wide end or 225 millimeters at its narrow end. We also needed to find a panel layout that maintained a ratio of at least 25% of straight to tapered panels, as it would make the installation process faster and reduce the cost overall. We tried different options. We used Dynamo to help us distribute the panels, but it did not give us an output that met all our requirements. In the end, we used Dynamo for the straight panel layout and decided to distribute all tapered panels manually. This also gave us an overall greater control. We finally managed to keep all constraints and could even increase the straight panel ratio to 54%. It was a great result, and it meant that the installation time on site would be quicker and would further reduce the overall cost. The panels look the same when looking from a distance, but at a closer look, you can see that almost every panel is different in size. Because we follow the curve of the roof extents, many panels have different lengths. We, therefore, needed to create a Revit family that could be adjusted accordingly whilst being confident that these changes would not impact any other panels. The same was required with the distribution of the C-channels and halter clips along the steel structure. The height of the C-channels was different in every location. With this level of detail, we were able to produce a material order list for our client very quickly and with great accuracy. One of the most critical factors when working in BIM and creating a coordination model is understanding the goal we need to achieve. Ultimately, our main goal for creating this model was to find any possible issues that might cause problems during construction and eliminate them before they do. We achieved this by asking the right questions. We focused on the design, but it was essential to fully understand the construction methodology and the installation process itself. For me, creating a BIM model is like a construction rehearsal, where we build the project virtually first, and the coordination process is like practicing. The more you practice, the fewer mistakes you make. Good communication with everyone involved was the key. During our coordination process with the client, we prepared all questions and explained them through drawings, sections, graphics, and of course the model itself, and even sometimes through video recordings. In my experience, everyone wins using BIM. It is just in different measures. The designer wins because work can be planned better. The design process does take longer because of the coordination element. Still, in the end, if a project is well coordinated, then there aren't as many questions coming back during the construction phase. It not only saves time and money for the designer, but ultimately also for the contractor and the client. Subcontractors win because they get more information through the BIM process, be it possible problem areas they can prepare for before they are on site. In addition, they get more information through measurements and very accurate material lists. The most important key here is that coordination before construction start is crucial, but too often it is still disregarded or not enough time allowed for it. Now I would like to finish my presentation with our most important lessons learned from this project, which also will apply to yours. Preparation is key. Understand your design and analyze how the model should be structured with repetitive elements and components. Optimization. Design and model optimization will save time, money during planning and construction. Design with the reality in mind. Never forget to think about how whatever you design or model is installed on site. It is for me the probably most important point. We can spot the problems before they can cause profound implication with this mindset. Questions are important. As philosopher Eugene Louis Wordsworth put it, and I'm going to use the censored version, assumption is the mother of all mistakes. So if anything else, remember to ask and never assume. And last but not least, don't forget, everybody wins. Thank you very much for listening. I hope you were able to find some valuable insights from my presentation. Please feel free to connect with me through LinkedIn. I or anyone on our team is always happy to give advice when needed. And before I forget, feel free to ask questions in English or Polish. Both options are okay. I chciałabym tylko dodać, że chętnie odpowiem również na...
Let me just answer that I will be happy to answer the question also in Polish. Thank you, Monika.
Thank you, Monika.
Thank you for showing. That was a very interesting project of a hospital in Dublin